This is a vending machine that rents videotapes. If I want to rent a movie, all I do is insert my credit card in here, enter some information about the particular movie that I want to rent, and if everything goes well, in just a second or so, my movie pops out of the machine. But this is also a terminal on a computer network, and it has the same problem as most computer networks. Lots of terminals, lots of users, and the need to control access to the software. So it has certain security systems built into this computer network. Today we take a look at PC network security on this edition of the Computer Chronicles.
Computer Chronicles is made possible in part by Central Point Software, suppliers of utilities software, including disk backup, data recovery, file and desktop management, and virus protection. Central Point Software, making computing safer, simpler, faster. Additional funding is provided by the Software Publishers Association, which reminds you it's a federal offense to copy software, and by PC Connection and Mac Connection, and by Byte Magazine and Bix.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and with me this week is Jan Lewis. Jan, everybody knows what a PIN number is by now, personal identification number. You need it when you use your bank card, you know, to get into that ATM machine and so on. Well, this is a network security system from Security Dynamics. This card is called the Secure ID, and this is a system a couple million times more safe than just the PIN number because this adds 6 digits to your 4-digit PIN number. And this changes passcode every 60 seconds. So for example, if I want to get into the system, let me show you. I'll enter my PIN, and then I'll enter the passcode number that's up here right now. And I got into the system. Now, if somebody had seen me do that, sort of copy down my passcode number, it wouldn't matter because 60 seconds from now, the ID number will change and they couldn't get into the system. Anyhow, it's rather interesting. In talking about PC network security, it seems to me there's a tug-of-war going on here. In a way, you want it to be very difficult for people to get into that network. On the other hand, you want it to be easy for people to use the network. How do you balance those two interests? It's
a very hard balance. It's the balance really between security and the autonomy that the personal computer has brought to people. In some applications, like financial, it's very clear that security has to win out. But really more often what we're seeing is in corporations where there's a battle between the network administrators and the individuals who are sitting at their own PC. They may want to do something like bring a disk in, put the disk in the machine, and do something with it. On the other hand, the network administrator doesn't want that. They say, give me the disk, we'll virus check it, we'll do everything we need to do, and we'll control it. And that's a battle that's going on right now.
Jan, today we'll look at several approaches to solving the problem of PC network security for both PC networks and Mac networks. Market researchers say that in fact 30% of today's standalone PCs will be networked by the end of 1992. And that means facing up to security problems. To find out more about the problem of PC network security, we called on the network expert at PC Computing Magazine, Raphael Needleman, and here's our report.
A lot of computer products come under close scrutiny and review at this InfoWorld magazine test center. But one thing the technicians have yet to find is a local area network system entirely safe from prying eyes. Surveys show that by 1994, some 65% of PCs will be networked. The advantages are clear: access to shared files, electronic mail, and even the ability to share peripherals such as printers. Experts say it is exactly this flexibility that makes networks vulnerable and open to attack. But they add that it doesn't take a disaster before security measures go up.
People can be convinced of that they need to control access to their data by quite little things. If you compare a file on a computer to a printed file in somebody's file cabinet, it becomes pretty clear to people that sometimes a file cabinet needs to be locked.
Locking the contents of that file cabinet in the computer can be done in a number of ways.
Most secure networks are designed from the beginning using common sense, using the features of security that are already built into the networks. For example, if your network has password protection for its users, and they all do, you should make sure that each user has a password.
But the level of security finally depends on the sensitivity of the data. The more important the information, the greater the need to protect it.
Implementing network security is like buying insurance. It is at first appears like shoveling money and resources down a hole until you really need it, when all of a sudden you've saved the day.
For the Computer Chronicles, I'm Susan Chase.
The problem of controlling network access is twofold. There are users who need to access a network from a terminal connected to the system, and there are users who need remote access from a distant location. Here to show us a variety of solutions for Macintosh networks are Francine Dubois of ASD, and also with us Larry Jones of Farallon Computing. Jan?
Larry, there's a lot of talk about computer security. A recent survey that I saw showed that 91% of the top executives of companies were concerned about network security, but only something like 65% of them actually had a program in place to take care of it. What do you see as the dynamics in that market and how that's happening?
We're seeing a great increase in the requirement for security, and at the same time a great increase in the demand for things that might break security. So for instance, the dial-in product that we're going to show today offers a lot of opportunities for people, unauthorized users, to gain access to an internet. But at the same time that these needs are growing, we're also seeing more concern about how are we going to protect that corporate internet from unauthorized access.
All right, Francine, let's turn to the slightly smaller situation. You've got a Mac or maybe a small network of Macs hooked together. You've got two things you want to show us, I think, MACsess or MACsess card.
MACsess card reader.
Okay, MACsess card reader and FileGuard. Now,
yes.
Show us and tell us how this all works.
Okay, well, FileGuard is the software, and MACsess card reader is additional security for people who already have FileGuard. It's not independent at all. Okay, right now, if we look at what I have on the screen, people will recognize folders, the sign of an application, FileGuard's icon, and another folder, which is all gray.
Yeah.
If I try to open it right now, it tells me I cannot do it. Okay, just to be sure, okay, the user is Larry, and Larry,
and that's
well,
not you.
No, it's not me, and he can't. Well, what I will do now, I will take a credit card which has been programmed to be able to go in the MACsess card like any other MACsess card. As long as you have a magnetic strip, it will recognize it.
So you could put your ID, your password on any credit card?
Exactly, on any credit card. It depends a little bit about something in here, really magnetic details or something. Anyways, if I go right here and do this, we're going to see a little message appear saying Francine as a user has been recognized. And now if you look a little bit better at here, I don't have any dimmed kind of folder any longer.
The folder is now accessible.
I can open it.
Okay.
If I go right here and I open it, I have various other folders, an icon of a little file with a key on it, meaning it is protected. It has been encrypted, as a matter of fact. I will show you how I can open it. Also another kind of an application and various other things. And another icon, which is pretty different this time, with a little arrow, means I cannot open it. If I try, I cannot, but I can drop things into it. It's called a drop folder because I have assigned various privileges to it. Let's say that FileGuard in general works with various configurations, and I'll go into that immediately. There's an administrator. He's the only person who can access that. I'll type his access key, and here I'll get to a specific kind of window where I have all the users, I have a guest, a lot of various users, they have the same icons, and a specific user who has a little different icon, who's the administrator. And he is the one who defines the various privileges the various people can have. So they can, for various kind of files, either create, open, delete, lock, unlock, or see the history of those files. He also can assign other privileges regarding the fact that he can protect folders, he can erase disk or cannot, copy applications, etc. I mean, various configurations. So I'll just get out of here just right now. According to that, the icons will change. Let's go, for instance, if I'm right here, Francine, I can do everything. I gave myself a lot of privileges, or the administrator has. If I go back to change user, and I can be a guest, if I go to guest, well, strangely enough, my folder is empty, and you have those little icons right here, meaning he cannot write, he cannot see the folders, and he cannot see the files inside. So basically, that's very nice security. If I go back to Francine, I'll take the MACsess card again, go like this. We'll see all the various things I can do. I can also see that this file has been protected, sorry. It requires the password. So if I give the password, we'll see very quickly that it has decrypted the file. And then when whatever I do, I can open it, do a lot of things. And in order to re-encrypt it, which is automatic, I mean, I have asked for it, I just need to, well, I can modify whatever here, and then validate, get out of the application, I'm quitting, and right here, same changes, yes, okay, let's change them. And it re-encrypts it automatically.
Francine, I need you to turn the Mac over to Larry now, because I want to take a look at the other situation, which is, say, the guy working at home or whatever wants to access the corporate network through a telephone line. How does PhoneNet provide security in that situation?
The Liaison product is an AppleTalk router that allows a Macintosh to connect across a modem link to a remote local area network. So it's as if I picked up my Macintosh, drove it across town, and attached it to the local area network. I have full access to all the services that I would normally have at my remote network, such as printers and file servers and that sort of thing. So to access network, you use the chooser in the Macintosh. So we'll select the chooser and open it up. And here's the Liaison icon. I select Liaison and it gives me an address book. I want to dial into the Farallon corporate network, so I'll press the dial button and ask me to enter the password connected with this account. And it's now placing the call to the Farallon network. Now, at Farallon, we're quite security conscious about who we allow access to our network, and so we use a feature called dialback. What dialback does is, as soon as the remote end at the network server finds out who is calling, it drops the phone line. Once it knows who's calling, it looks into its database of authorized users, finds out whether I'm an authorized user, and picks the phone number attached to that record.
Yeah, we can see what's going on the screen now. It's made the call, and now it says it's waiting for
a return call back from the network server.
Now, what's going on at the other end right now?
What it's done is look into the Liaison database, which has been set up by the network manager, and our network managers control who has access to our corporate internet. And the thing about dialback security, and what you can hear now, is that we're receiving that call back from our...
And it found your number in its directory.
It found our name and number and called us back. And the big difference is that password security lets the network manager control who is dialing into the network. But the added advantage of dialback security is that it lets them know where it is they're calling from. So if an unauthorized user is trying to access our corporate network, they would have to come actually back to my home to receive this dial-back call, which is obviously quite a difficult feat.
Now, what if you want to give someone access to the network, call them back, but only give them access to certain files, let's say, or certain portions of what you have on that disk?
One of the things that Liaison allows you to do is it allows the network manager to control who gets access to specific portions of the network. So for instance, at Farallon, one of the things that we do with Liaison is give our customers a dial-in account. So they can dial in, get technical updates, get technical information, but they have access to only one specific server on our internet. So our network managers can feel comfortable about the security of our internet while still serving our customers and giving them the service that they need.
Larry, Francine, we're out of time. Thanks very much. Well, perhaps no single person has publicized the problems of global network security more than Cliff Stoll, author of the best-selling book Cuckoo's Egg, about his effort to track down a network intruder. We visited Cliff at his home here in Berkeley, California.
4 years after he uncovered a ring of German hackers, Cliff Stoll says he is still busy answering letters and giving speeches on computer security. The international computer break-in he discovered at the Lawrence Berkeley lab, he says, has continued to have a profound effect on the industry.
People are auditing their computers more often. They're watching to make sure that their systems aren't left wide open. They check their balances more often. And they're also more aware and more worried about things like viruses and outsiders breaking in. People back up their data more often now than they used to.
The German hacker Cliff tracked down used the Berkeley system as a hub to reach other computers across the United States, including those of the military. Of the 450 he attacked, he successfully entered more than 30. Cliff says the network administrators were not doing their job.
This hacker was able to get into the systems not because the systems were themselves insecure. He was able to get in because nobody was watching their own computers. They would connect their computers to a network and never bother to think about security. They'd say, oh, we're on the network, it's useful, we can send mail all over the place. But they never realized that although they could get out from their computers, other people could get in.
Any system, unless it is totally isolated, can be penetrated. But the answer does not lie in securing the network, Cliff says. Rather, much like houses in a city, each individual unit needs to be protected, not the pathway leading to that unit. The data contained in that computer can then be safeguarded by encryption.
I suspect we're going to find more and more people worried about how can I encrypt my data? How can I encode my data so that others can't read it, except for the one person who wants to see it?
For the Computer Chronicles, I'm Susan Chase.
There are other aspects to network security besides just access controls, such as virus protection and control of software use. To show us some more security solutions, we have with us Bob Lewis of Brightwork Development and also Jim Bidzos of RSA Data Security. Jan?
Jim, in the first segment, we took a look at some security aspects of small or local networks, 5, 20 people, whatever. But now, of course, we're dealing with the global networks, and surely the scale has changed and the kinds of problems and the kinds of solutions have changed. Can you give us some idea of how they've changed?
Yes, the problems are magnified considerably when you get into a large networked environment as opposed to a small LAN or a single computer. The security problems are immense. However, an advanced technology known as public key encryption can in fact provide the kind of security that can secure these networks without denying the open access that everyone has gotten used to and in fact is the reason that people have started to note security problems. The open access has created the problems, and there is a technology that can correct them.
All right, we're going to talk about your approach, your encryption approach in just a minute. I want to turn to Bob. Now, you have a product called SiteLock. I was just mentioning problems like software control and viruses. You address those problems with SiteLock. Tell us a little bit more about it.
Well, we allow for the network manager to really control all the software that's run on the network. We do this in several different ways. First, we meter the software that's used so as not to exceed the number of licenses that the company owns. So in other words, if you have 10 copies of WordPerfect, only 10 people can run WordPerfect at a time. We also provide virus protection, and in doing so, we go out and do a bit-by-bit check of every file before it's executed. And if it detects any changes in file size, it doesn't allow that file to be run.
All right, Bob, tell us about the software metering part of SiteLock. How does that work?
Okay, what you would do is select the application you want to meter and go in and select the maximum number of concurrent users that you want to be running, which would correspond to how much software you actually own. And then when I go out, here we've selected one user. So if I go out and run Syscon, I have no problem getting into it. But if Janowit's going to try to get into it...
So you're running it over there on your terminal. Now, Jan tries to run Syscon.
Okay, here I go. Let's see what happens. Access denied.
Yeah.
She's denied because there's only one concurrent user available, but she gets queued up. So that means when I release this copy of Syscon, she'll get another message saying that she has 5 minutes to get into Syscon.
Okay, let's see if it works this time.
Okay, now SiteLock does let her get in. Bob, do you have a way of keeping track of what's going on the network and knowing that somebody had to wait in line to get into an application?
Sure. This is an activity report that we've run for Syscon, which shows all the users that logged in, when they logged in, and if they got queued up. And it's a good barometer for a network manager to use, because if he sees a lot of users queued up around the same time, it's an indication he needs to go out and buy some more software.
All right, what about the virus protection part of SiteLock? Show me how that works.
Okay, we've got a file called I, which has been virus protected under SiteLock, and I'm running it here.
So it runs fine right now.
No problem here. But if I go out and corrupt it and change the signature so SiteLock doesn't recognize it, which I'm doing right now, and try to run it again,
all right.
I get the message that the file's been changed, SiteLock doesn't understand, recognize it, and it's not going to allow it to run. Now I can restore that to the original version and run it again, and it'll work.
All right, what else can you show us about the virus part of SiteLock?
Okay, we want to get back into the main menu here. And we can really prevent any unauthorized software from running on SiteLock, with SiteLock. And the way we can do that is go down to virus protection and define unprotected files. And now what I've got is it's set up so that unprotected files, virus-protected files, are not allowed to run. So if Jan would try to run map or something like that, which is not virus-protected.
Okay, this is not virus protected, and let's see if it'll run it.
And it won't let you run that either.
Right.
And it gives me that message, not virus checked.
And the last thing I want to show you is the ability to restrict usage of local drives for users. So if you want to clear that bottom message and get down to your
A drive?
Your A drive.
So if she tries to load her own software here.
If she tries to execute,
I'm going to execute now something called
Okay.
video.
And she can't do it, yeah.
right.
All right, Jim, let's get back to the subject of encryption now, and your product which is called MailSafe. What does that do?
MailSafe is a product that performs a advanced and unique kind of encryption called public key encryption. And maybe I can explain it to you while I go through a demo.
Great.
Great. Okay, the first thing I would do is bring up the MailSafe program. You can see it's running a self-check, which is kind of an antiviral mechanism that we built into it. It detects the more obvious kinds of tampering. There may be many users on a single computer who share a copy of MailSafe, so I'll identify myself and then I'll enter my password. I'm now ready to perform MailSafe's 4 main functions. They are, as you can see, to put a signature on a file, create an envelope, open an envelope, or verify signatures. And again, maybe the easiest way to show you is to just do it.
Yeah.
So let's say we want to sign a file. We can navigate our way through DOS's file system here nicely with MailSafe. It works very well with the mouse as well. And here we have a little file conveniently called test file. And we can even take a look at it. It appears to be some sort of a letter here that purports to want someone to spend money. So let's assume it's maybe a funds transfer document or something very sensitive, something certainly worth protecting. So we want to now sign the file. It says hit enter to sign it. What we're actually doing with this signature is affixing some data to it that is unique to that file and unique to me as a signer. This doesn't offer any privacy. This is data that's going at the end of the file. But let's decide that before I send it off to my recipient that I also want to encrypt the file for privacy because I don't want anybody to see it. A good example of not needing an envelope, putting a signature on a file is in my company I might put a note on a bulletin board that says everybody has Friday off. I certainly want them to be sure that that came from me, but I want everybody to see it. As opposed to Steve, you're fired. You know, I don't want anybody else to see that. So I'm going to encrypt this file now, put it into an envelope. Now the first thing I have to do, because of the very nature of public key cryptography, since it's going to be encrypted in a way that only the recipient can read it, I need to identify that recipient to the system. So for convenience, this is a very real example, by the way, of public keys and the useful names that are associated with them. I'm going to encrypt this for myself just as a matter of convenience so we don't have to get in and out of the program. And now what I'm going to do is create this encrypted file. The program knows to overwrite an existing file out there already. Now, at this point, I would get out of the system and mail it to whoever I was sending the program to, the file to. And they would receive it, and then they would do the following 2 things. They'd receive it and they'd open this envelope. Get back into our file there. And we get ready to open it. Now, I might want to show you what this file looks like. You can see it's encrypted with some information at the end. But those unreadable characters up there are the resulting encrypted file. And as you may have heard about our system, essentially what we did in the few seconds that we took to encrypt that file cannot be undone by even a bank of Cray supercomputers in millions of years. So there's a lot of security that goes with this. So let's go ahead and open the file. And now, as a recipient, we can also verify the signature on this file. Now what happens when we get through this process? After I've opened the envelope and verified the signature, which I see is valid, I now know the following things. I know that this file came from the person who claims to have sent it, and that not one single bit has been tampered with. The signature is very much like a tamper detection seal for software. And I also know that no one else has seen the file. For example, in the internet, if you're familiar with the internet community, typically a piece of mail sent from one person to another goes through dozens of computers before it gets there. And the operators of these computers are, I'm sure, trustworthy people, but
Curious people.
We have only a little bit of time left, and I think, Jan, you had a question about the users of this.
I wonder who is going to buy this. Is this individuals who buy it, or is it the government who buys it? Who's this for?
Well, both those people have bought this particular product. This is an end-user product, but it's really not the main part of our business. What our company really does is essentially work with large computer systems manufacturers, operating systems companies, to get this integrated into their computers. A recent report called Computers at Risk, put out by the National Academy of Sciences, identifies public key cryptography as the backbone of any secure operating system that really needs to be there. And over the last 5 years, we've worked with essentially vendors covering every major platform. And over the next 12 months, hopefully we'll see some systems coming out on the market that have this embedded.
Jim, in 15 seconds or less now, I know the National Security Agency is a little bit unhappy about what you're doing. Why would that be?
Governments in general are very concerned about privacy technology. All governments around the world, not only the U.S. government, but all of them do treat this as military technology, and it's a controlled commodity. It also threatens the intelligence missions of government agencies around the world.
Interesting. Gentlemen, thank you very much. That's our look at PC network security. Stay tuned now for this week's Computer News.
In the random access file this week, Lotus says it is now beta testing the new Windows version of 1.2.3. The company says it normally takes 3 to 6 months before all the bugs can be worked out, but it hopes to have the new Windows version of 1.2.3 on the market by the summer. Symantec has brought out a new low-cost word processor called Just Right. The company claims its new product packs all the power of the much pricier competitors. Just Right runs under Windows, and one of its main features is its ability to automatically import or export files from other word processors. Just Right also offers network file locking and a complete messaging system on any Windows-supported network. Just Right will sell for just under $200. IBM says it's cutting the cost of the one-time license fee for OS/2 version 1.3. The announcement comes just as Big Blue is gearing up for the official release of OS/2 version 2.0. With the price cut, the standard edition of 1.3 will cost $150, down from $340, and the extended edition will sell for $690 instead of $830. Taking a look at this week's top 10 software titles for the Macintosh, Mac Connection reports that After Dark is in the #1 position with Sam in second. Third is KidPix, followed by Mac Utilities and Microsoft's Word. Rounding out the top 10 are Adobe Type Manager, Managing Your Money, Disk Doubler, Quicken for the Mac, and Excel. Tandy has introduced a new 286 home computer that will come bundled with a variety of home management applications. The 1000 RLX is a 10 megahertz machine that features 1 megabyte of ROM, VGA graphics, a 3.5-inch floppy disk drive, and a PC-compatible expansion slot. The basic model of the new Tandy computer will sell for just under $800. A hard drive is optional. And finally, don't leave home without it. Contech International has come out with a computer pointing device the size of a credit card that fits easily into your pocket. The Pocket Pad is a touch-sensitive input device, and it features a row of buttons on one side for easy command input. The Pocket Pad connects to your computer through the serial or mouse port. That's it for this week's Computer Chronicles. I'm Kate McGargy.
Computer Chronicles has been made possible in part by Central Point Software, makers of Central Point Antivirus, a comprehensive program for the detection, removal, and prevention of more than 500 computer viruses. Additional funding has been provided by the Software Publishers Association, which reminds you it's a federal offense to copy software, and by PC Connection and Mac Connection, and by Byte Magazine and Bix, the Byte Information Exchange.